All right, so in this lecture, as I said before, we're going to look at where to go to get the CAS or CAS Modbus scanner. All right, so I'm in my browser and I went to this site called chipkin.com, chipkin.com. All right, so when you go to that site, this is what it'll look like. You go to products, software, and then you go to Modbus software. All right, and here what you'll see, if I'll scroll a bit, and you'll see CAS Modbus scanner, or CAS Modbus scanner as I call it. And that's it. So this is the CAS Modbus scanner page. And if you scroll down, this gives you a screenshot there. Excuse me. And this is the executable file. So this is the installation file. So you click on this and you download it and then you install. Again, I'm not going to go through the installation. You all should know how to install software by now. If you don't, get someone to help. And this here, if you'd like to download the data sheet, it just has some basic instructions, but really and truly, it's really easy to use. So it's up to you. You can download it if you want. All right, and that's where to get the CAS Modbus scanner. So in the next lecture, we're going to look at basic usage, hexadecimal, and that sort of thing. Okay. All right, let's look at the data traffic for the read coil status command. So we have our coil here in our Modbus server. And what we're going to do right now is, see, disconnect there. I'm sort of going to clear the data traffic for that. Start this new window up here. And we're going to go 21 and address 10 and 1. Right, we have coil status. I'm going to click on show traffic and we're going to connect. And we have some traffic there right away. So we're seeing 228.03 is the identifier, transaction identifier, and the protocol identifier. Then 6 is the length, and 21 is the unit ID. 1 is the function code. 09, which is of course 10 minus 1. 1 is the lower limit of the coil register area, and then 01 for 1. And then everything is reflected. 21 and 0. 01 is the function, 01 is the number of bytes expected back, and this 1 here, of course, is the status of the coil, right? And there's another transaction right after that with the pole. So that essentially is our data traffic for the read call status command. As you can see, all of the commands follow the same format, but I just wanted to take my time and go through all of them with you so you have an idea and you can simulate it yourselves. The next few videos, what we're going to look at is the data streams for force single coil as well as preset single register, because you'll need to know those when you're actually troubleshooting as well. Okay. So thus far, we have simulated 4 Modbus functions using our Modbus TCP/IP simulated network right on this laptop with ModScan32 and ModSim32. And these functions are read coil status, read input status, read holding registers, and read input registers, all on TCP/IP. We still, however, have 2 more functions to simulate, and those are, you would recall, force single coil and preset single register. Unfortunately, ModScan32 does not support these 2 functions, so we're going to have to use another Modbus master simulation application, and the name of that is called the CAS Modbus scanner. In the next lecture, I'm going to show you where you go to download CAS Modbus scanner, after which I will ask you to go ahead and install it. Okay, so let's look at the data traffic for that read holding register command. So we have our ModSim32 server set up here, and we have selected data traffic or show traffic here. So I'm going to set this up 22, and that's going to be 21, and that's going to be 1, and holding register. So let's look at some traffic. There we go. Okay, disconnect. So I have my transaction identifier 1, and then protocol identifier 00. 06 is the length, 22 is the unit ID, 3 is read holding registers function code, 20 is the start. Remember, 40,021 minus 40,001, and 01, which is the number of memory address locations that we want. And everything, the mbap header is reflected, unit ID, 3, 2, 2 number of data bytes coming back, and here's our 30, which is the value coming back right there. So it's pretty much like the read input registers, but I still wanted to go through it with you. All right, good.